Temperature is stable. Proceed with the primary compression cycle.
The thermal gradient looks consistent. No signs of microfracturing in the grain structure.
Surface tolerances are within 5 microns. We are ready for the thermal tile integration.
These tiles must withstand 5,000 degrees. There is no room for error in the adhesive bond.
Signal continuity is green. All sensors are communicating with the main telemetry unit. Chamber is sealed. Initiating vacuum drawdown now. We are at Mach 6. Skin temperature is peaking, but the ceramic tiles are holding.
Exceptional performance. That is a successful certification run.
No visible ablation on the leading edge. The material integrity seems perfect.
Peak heat flux remained within the safety margins. The composite performed better than the simulations predicted.
0.02 millimeter deviation, still well within the flight-ready specification.
Looking at the crystalline structure now, the heat didn't cause any phase shifting in the ceramic.
If the next batch of titanium holds up in the forge like this one, we can start the full-scale production.
Great.
Ready for the second run. Keep the pressure ramp up gradual this time.
The heat signature is identical to the first. We have a repeatable process.
Good work today. We'll start the stress tests on the second unit tomorrow morning. The second unit is within spec. Let's move to the stress mounting immediately. Sensor 32 is seated. Checking the light path continuity now.
Link is established. The second unit is transmitting clean data across all channels.
Secure the aft clamps. We need absolute stability for the Mach 7 attempt.
Ignition. Airflow is stabilizing at Mach 6.8.
Vibration is hitting the red line. Hold it together, just 10 more seconds.
That's it. Shutdown complete. We just hit Mach 7.
The data is perfect. This design is ready for flight.
Let's look at the internal heat sensors first. I want to see how much heat soaked through the tiles.
The secondary insulation didn't even scorch. The bond held the thermal load perfectly.
We need 3 more billets forged by tonight. Start the preheat on Unit 4.
Temperature is at 1200 degrees. It's ready for the primary stroke.
Clean release. The geometry looks perfect, even before the final milling.
The grain flow in the second forge is identical to the test unit. We have achieved full repeatability.
Authorization sent. These units are officially cleared for the flight test range.
See you at the launch site. Tomorrow is going to be a big day.
I want one last reading on the thermal expansion gap before we crate it.
The porosity of the ceramic coating is perfectly uniform. It will handle the plasma friction.
Steady, hold it right there. Center it on the lower die.
Core temperature is holding at 1100. Proceed with the first compression.
The geometry looks stable, no warping during the quench.
Let's recalibrate the sensors for the Mach 7.5 simulation.
Sensor 4 is live. Check the feed on the main console.
Vacuum is at nominal pressure, standing by for plasma generator ignition. Plasma stable. Increasing velocity to Mach 7.5.
Boundary layer temperature is exceeding 4,000 degrees. Watch the leading edge sensors.
Test cycle complete. Initiating nitrogen purge for immediate inspection.
Minor surface oxidation, but the structural depth is intact. The tiles held at Mach 7.5.
Let's get the laser metrology grid set up. I want a final geometry verification.
Connectors are secure. Signal loss is less than 0.1 decibels. Internal sensors survived.
The dataset is complete. Every metric confirms we are ready for the live flight test.
It's been a long 6 months. See you at the range tomorrow at dawn.
The backup flange is within tolerance. Secure the lot for transport to the range.
Surface tension is optimal. The bonding agent hasn't degraded during the final cure.
Chamber 1 is locked down. All systems at standby.
Remote telemetry is live. The range is receiving our pre-flight packets.
Transport leaves at 0400. Make sure the thermal logs are uploaded before then.
The simulations and the tests are aligned. We've done everything we can.
See you at dawn. It's going to be a historic flight.
Lights are up. Let's verify the crate seal before the transport crew arrives.
Internal pressure is holding. The inert gas environment is stable.
Uploading the final calibration set. The range needs these parameters for the tracking radar.
She's ready. Let's get the lid on and secure the locks. Forge is cold. Everything is locked down for the duration of the flight test.
Transport is pulling in. It's time to move.
All test chamber data is backed up. Standing by for remote link up at the range.
Today, we make history. Mach 7 is just the beginning.
The atmospheric conditions are perfect. Visibility is over 10 miles.
Handover complete. Range control has full telemetry from our internal sensors.
Ignition is scheduled for 0600. We have 5 minutes to reach the observation hub.
Booster separation confirmed. Entering the hypersonic corridor now.
Crossing Mach 7.5. Thermal tiles are holding at 4,000 degrees Kelvin.
No structural deformation. The ceramic composite is behaving exactly as it did in the test duct.
We've reached Mach 8. Sustained flight for 60 seconds. We have parity.
Exceptional work, scientist. That data is going to rewrite the aerospace manuals.
Let's get some breakfast. We have a lot of data to analyze before the afternoon briefing.
It is rare to see this place so quiet. The data from today will keep us busy for months.
Yay.
Look at the heat dissipation here. The titanium core did not even hit the thermal limit.
We started this project with just a raw titanium billet. Seeing it reach Mach 8, it is something else.
Yep. Yes, @car_2. Your precision in the forge made my math work. We could not have done it without those tolerances. Look, the ceramic bond did not just hold, it actually tightened under the high G load. That is our breakthrough.
Report is filed. The next phase of production is officially greenlit.
To Mach 9 and beyond.
It is hard to believe we actually did it. The forge will feel different tomorrow.
I'll have the structural integrity report on your desk by Monday morning.
All systems to standby. Security sweep initiated. Plasma banks offline. Vacuum manifolds sealed. Rest now. You've earned it. Project Hypersonic, Phase 1, complete. One last look, just to be sure everything is settled.
You held up your end of the bargain today.
Cooling rates are perfectly linear. The core thermal mass is stabilizing right on schedule.
Sealed and secured. Ready for the next run whenever they call for it.
Final shift report for Project Hypersonic. All hardware certified flight ready. Facility entering standby mode.
Good night, everyone. See you at the launch.
The heat dissipation is following the logarithmic decay perfectly. The bond is stable.
Tomorrow is for the analysis. Tonight is for the rest.
Certification is complete. We are flight ready.
Back to the grind. We have data to verify.
Grid alignment is within 2 microns. We are ready for the next assembly phase.
The expansion at Mach 8 was localized here. We should adjust the forging pressure on the next core.
Base geometry is identical to the first unit. Let's begin the internal wiring.
Channel 4 is showing a slight drift. Technician, check the primary fiber optic connector.
Connector reseated. Scientist, check the signal integrity now.
Signal is nominal. We are a go for the secondary pressure test.
Chamber is sealed. Initiating evacuation.
Vacuum drawdown is at 60%. The structural seals on the second unit are holding firm.
There is a minor resonance in the aft support. Scientist, can you cross-check the vibrational harmonics?
I see it. It is within the expected deviation for the new forge pressure. Proceed to the ignition sequence. Surface temperature is passing 3,000. The composite is stable.
Resonance is peaking. 10 seconds at maximum load. Hold it together.
We have achieved steady state. The second unit is outperforming the first.
Test cycle concluded. Initiating primary cooling purge.
Let's get this data to the assembly bay. We need to start the final certification report tonight.
The nitrogen purge worked. The core is cool enough for a tactile inspection.
Structural deviation is less than 0.03. The titanium core maintained its geometry perfectly.
The heat didn't even penetrate the primary adhesive layer.
We can likely reduce the tile thickness for the next iteration.
Data packet exported. The board will have the certification evidence by dawn.
Everything is clear. Bay is ready for the night cycle.
Tomorrow we start the production run. Good work, scientist.
Certification is locked. Let's start the preheat for the production billets.
Heat distribution is optimal. No cold spots detected in the core.
First production stroke complete. Pressure curve is perfect. That is 1 down, 19 more to go.